Today, I want to talk about how to prove that an expression will always result in an even output when the input is any integer. So here we have our proposition. If n is inside the integers, then n squared plus n is even. Okay? So how do we go about showing this? Well, an integer can either be even or odd. So in our proof, we're going to have two cases. One case where the integer is even, and the other case where the integer is odd. Okay? So we'll start with case 1. Right? And in case 1, we'll have n is even. Okay? And now what we really need to do is think about, what does it mean for something to be even? Well, it means it's divisible by 2. Well, that means we're going to let n equal 2 times some integer k, right? N equals 2k for some k inside the integers, okay? That's what it means to be even. Let me know if you disagree with that, right? But that's the definition of being even. Then, from there, what we're going to do is we're going to take 2k and we're going to plug it in to our n squared plus n, okay? So we'll get 2k squared plus 2k. And well, that equals 4k squared plus 2k. Then we can factor out a 2 here and we'll get 2k squared plus k, okay? Then we have this. Now we're going to let 2k squared plus k equal m for some m inside the integers. Okay, so we're letting it equal some integer m. So there we can say n squared plus n equals 2m, right? Which means 2 divides n squared plus n. Okay, and therefore n squared plus n is even when n is even. Now we're going to do the same thing, but for odd. So now we have case 2. N is odd. So now once again, what does it mean for something to be odd? Well, when something is odd, that means if you subtract 1 from it, it will be divisible by 2. So we can say we're going to let n equal 2k minus 1, right? That's the definition of being odd. You could also do plus 1 if you wanted to, and you would get the same thing in our case. But I'm going to do minus 1. So we're going to let n equal 2k minus 1. Therefore, it is an odd integer for some k inside the integers. Then, from here, once again, we're going to take this and we're going to plug it into n squared plus n. So we get 2k minus 1 squared plus 2k minus 1. All right, and this will equal 4k squared minus 4k plus 1 plus 2k minus 1. So these will cancel out, right? And then obviously this will become 4k squared minus 2k, right? And well, what do we notice we can do? Well, we just need to factor out 2. So this equals 2 times 2k squared minus k, right? And then we're going to let 2k squared minus k equal m for some m inside the integers, right? And as you can see, I haven't really left enough space for myself, so we're just going to take this up here, right? And that means that this will equal 2 times, this up here will equal 2 times m, equals 2m. Therefore, 2 divides n squared plus n when n is odd. Therefore, in both cases, we have shown that the result will be even when the integer is even and when the integer is odd. The output will be even, therefore proving that in any integer input, the output will always be even. Thank you for watching. Let me know if I say anything wrong or if you have anything additional to add. Have a great day.